Hey everyone, in this video what we're going to do is we're going to find the integral from 0 to pi of x sine of x divided by 1 plus secant squared of x dx using King's principle, or what it's more commonly known as, by changing the direction of integration. Let's begin by setting x to be equal to pi minus y, and differentiating both sides we have dx is equal to minus dy. This allows us to rewrite our integral as the integral from pi to 0 of pi minus y multiplied by sine of pi minus y divided by 1 plus secant squared of pi minus y multiplied by minus dy. And we can use the following identity to rewrite our integral without the minus sign. All we basically do is switch the limits of integration, and this allows us to get rid of the minus sign. Now remember, secant squared of pi minus y can be rewritten as 1 divided by cosine squared of pi minus y. And we can also use the following trigonometric identities, along with the fact that sine of pi is equal to 0 and cosine of pi is equal to minus 1, to rewrite sine of pi minus y is sine of pi multiplied by cosine of y minus cosine of pi multiplied by sine of y, which is just equal to sine of y. And we can do the same for cosine of pi minus y, and we get that that's equal to cosine of y. This allows us to rewrite our integral as the integral from 0 to pi of pi minus y multiplied by sine of y divided by 1 plus 1 over cosine squared of y dy. Now if we just expand the integral on the right hand side, we have the integral from 0 to pi of pi multiplied by sine of y divided by 1 plus 1 over cosine squared of y dy minus the integral from 0 to pi of y times sine of y divided by 1 plus 1 over cosine squared of y dy. And if we set our integral in blue equal to I, and we change the variable back from y to x, we get the following. That is, we have I is equal to the integral from 0 to pi of pi multiplied by sine of x divided by 1 plus 1 over cosine squared of x dy minus I. And if we add I to the other side, we get 2i is equal to pi multiplied by the integral from 0 to pi of sine of x divided by 1 plus 1 over cosine squared of x dx. And we can solve this integral using a u-substitution. So we set u equal to cosine of x, and then we differentiate both sides, so we have du is equal to minus sine of x dx, and then we divide by minus sine of x, so we have du divided by minus sine of x is equal to dx. And because we've used the u substitution, we need to change the limits of integration. So let u2 denote the upper limit of integration. We have cosine of pi is equal to minus 1, and let u1 denote the lower limit of integration, and we have cosine of 0 is equal to 1. Using this u substitution, we now have minus pi multiplied by the integral from 1 to minus 1 of 1 divided by 1 plus 1 over u squared du. And if we use the same trick as before, that is, we can get rid of the minus sign by switching the limits of integration, we have pi multiplied by the integral from minus 1 to 1 of 1 divided by 1 plus 1 over u squared du. And if we just simplify what we have inside the integral, we're left with pi multiplied by the integral, from minus 1 to 1 of u squared divided by 1 plus u squared du. Now remember, this integral is equal to 2i, so we can divide by I, so we have I is equal to pi divided by 2 multiplied by the integral from minus 1 to 1 of u squared divided by 1 plus u squared du. And this is a pretty simple integral to evaluate. We have pi divided by 2 multiplied by minus inverse tangent of u plus u, and if we evaluate what we have inside the square brackets at the limits of integration, we get the following answer: minus pi squared plus 4 pi divided by 4. Thank you very much for watching. Make sure to like and subscribe if you found this content useful. If you have any questions, leave them in the comment section below and I'll get back to you as soon as possible. If you also have any problems you'd like to see get solved, leave them in the comment section below and I'll make a video on them as soon as I can. I hope you have a great day.